In this video, we're going to look at two corollaries and we'll do one example. The first corollary, which I'm calling intersecting secants, says that suppose an angle whose vertex is outside of a circle, this is going to be the vertex of the angle, is formed by intersecting secants of the circle. Okay, so that means basically draw a secant, which is a line that goes through a circle and hits it twice, here and here, and then another one here and here. So we're making an angle out of these two secants. Okay, if the intercepted arc measures, well, we can see where they are. Here is one arc, and here is the second arc. And if they have measures x and y, which I'll write like this and then y right there, we want to know the measure of this angle that we will call theta right here. Well, if you recall from the previous video, well, this corollary is going to generalize what we did in the previous example. We'll look at it real quick. We have the same kind of a setup. Here is our angle theta right here. So how did we get the answer for theta of 59 over 2 degrees, given that the measures of the two intercepted arcs were 110 and 51? Well, it may not be obvious how we got this, but it would be if we look down here. We have 110 and 51 here. We took the difference of them and divided by 2, basically. So we got the 59 over 2 by saying 110 minus 51. We subtracted these two arc measures and went over 2. That's where we got the 59 over 2. And that formula works every time, as we'll see in this corollary. The answer to the measure of this angle theta, that we're calling theta right here, is simply x minus y over 2. I'll put absolute values around the x minus y because we don't know which of the two arc measures is bigger. We didn't state here. In my picture, I made y the bigger one, but it doesn't matter if you do the subtraction. If it's negative, you just take the absolute value of it and put it over 2. Very simple. All right, now let's do something just slightly different. Draw a circle. We've got the circle here with two intersecting chords. A chord, remember, is a line segment that connects 2 points on the circle. So A to B is a chord, and C to D is a chord, those two line segments. Label as E, the point E is the intersection of those two line segments. So our point E is right there. If the intercepted arcs have measures 55 degrees and 82 degrees. Okay, I just did my rough guess as to about what a 55 degree arc and what an 82 degree arc would be. So this looks like the smaller one. This is going to be our 55 degree arc. My picture does not have to be perfect. You trust the numbers that we label in the diagrams. So now we know this is 55 degrees. And on the other side, 82 degrees is pretty close to 90 degrees, which would be a fourth of the circle. Yeah, maybe I should have made it slightly bigger, but it doesn't matter because we trust the numbers. So this arc right here will label 82 degrees. Okay, we need to find the measures of the angles AEC, that's this angle right here, and BED. Well, BED, notice they will have exactly the same values. These are what we call, vertical angles or maybe opposite angles. They'll have the same value. So when we find the value of one of them, we have found the value of both of them. So for my hint, I said, obviously, sketch. we're going to sketch two new line segments. This says sketch AD and CB. So let's sketch. And when we do this, these two line segments are going to give us a couple of additional triangles. C to B. All right, so we have a new triangle, AED and CEB. And we're going to use those to figure out what these angles are. Okay, so the first thing we'll do is notice we know a couple of these angles already. And we'll fill them in the diagram as well. What is the measure of angle DAB? Notice I said DAB rather than DAE, even though it's the same value. So what is this angle right here? Well, let's see. DAB is an inscribed angle in the circle. DA and B are all points on the circle. The measure of this angle is 1/2 the measure of the arc that it intercepts. So I can say that that is going to be 1/2 the measure of the arc DB. And that we know. Arc DB has a measure of 82 degrees, so that's going to give us a 41 degrees. I'll leave off the degree symbol maybe on that one. So I know this is now, write it in blue, 41. Just like that. All right, let's do similarly to get this angle right here. I'll also put it in blue. The measure of angle ADC. I know ADE is the same angle as ADC, right? But ADC is an inscribed angle. So what is it? Its value. It's 1/2 the measure of the arc that it intercepts. It's 1/2 the measure of arc AC, which is 1/2, and we're given that was 55. So I will do, let's see, 1/2 of 55. I'll use decimals this time. That would be 27.5, so 27.5. Okay, so let's write that in. 27.5. Hopefully you can read that. We have 41 and we have 27.5. Well, therefore, we could figure out the value of this angle if we wanted to, because these three have to add up to 180. But instead, I will use by the Euclidean exterior angle theorem. What do we know? This angle, if we extended AE of this triangle all the way like this angle is an exterior angle to triangle AED. And an exterior angle we know is equal to what? The measure of angle DEB is equal to the sum of the two opposite two opposite angles, interior angles of the triangle. We've got this triangle, so this exterior angle is going to be equal to 41 plus 27.5. And that's equal to 68.5 degrees. So that is our answer. That's the measure of angle DEB. So I could write that in, I guess, 68.5, which means this is also 68.5. So we found the measures of both of these angles, which of course they were those measures are equal. Okay, now like we did before, let's generalize that in the next corollary. Let's see if we can figure out, because this one might be slightly easier, how would we get 68.5 degrees from the two arcs, 55 and 82? Well, 68.5 is in between 55 and 82, and it turns out it's right in the middle of 55 and 82. It's the average of those two numbers. So if I took 55 plus 82 and put it over 2, I'm going to get what's that, 137 over 2, which is 68.5. And that formula works. There's a formula that works every time, and we'll write that down here. Finish up this video, the corollary called intersecting chords. An angle whose vertex lies inside a circle and is formed by intersecting two chords of the circle, and the intercepted arcs having measures x and y, has measure theta equals what? Well, I've already drawn the picture, and note that I could have chosen as the two chords, I could have chosen this one and this one, and the formula would work exactly the same. I just have to pick this one. I chose to pick this one and this one. So how do we get this angle theta right here, which is the same as this angle? We simply add up, we take the sum of the two arc measures, x and y, and divide by 2. It's simply x plus y all over 2. Very simple.